So write down some conversion. Question note karo, then try for some time. We'll discuss. Write down these 3 questions. Quick. Take some time, then we'll go to the next topic. So I hope all of you are trying. Okay, try. Keep on trying. तापर हम डिस्कस करिबा. I hope all of you are trying. Okay, quick. Last 2 minutes, then we'll discuss. Last 2 minutes, quick. I hope all of you are doing. Okay, now everything cure. First is it is the conversion into alpha hydroxy carboxylic acid. Okay, you can see alpha hydroxy carboxylic acid. Then मन पकाओ alpha hydroxy carboxylic acid ପାଇଁ ଆମେ जो preparation ଆମେ reaction लिखिथिले, so that is the hydration of cyanohydrin. Hydration of cyanohydrin. So जो compound तो मु देछि, that is the propane को आम सायनहाइड्रिन सहित ट्रीट करें और प्रोपेन रो सायनहाइड्रिन डायरेक्टली बन पारि. सो सायनहाइड्रिन कौन बना जाए, इधर आल्डिहाइड और कीटोन रो. ठीक. सो आम पाखे जो अच्छी प्रोपेन ताको हमको कीटोन रे कन्वर्ट करिया पड़िबो. व्हाई टू कीटोन? बिकॉज जो तुम सायनहाइड्रिन मस्ट बी फॉर्म्ड एट द पोजीशन 2. So how to convert alkane into ketone? It is not directly. First, you can write the bromination. So from bromination, you will get 2-bromo. Then treat it with aqueous cabbage. It will be propan-2-ol. Then use PCC, propanol. You can use HCN to get this. Then make the hydration. Okay. So write down the answer first. This is the conversion to the first question, propane to 2-hydroxy propanoic acid, 2-hydroxy 2-methyl propanoic acid. Quick. Over. Now come to propane to butanol. Propane to butanol. So नाम जन देखिए some methods are there जो थी हमें कार्बन नंबर को इंक्रीज करि पारे ascending order कहंती. So ascending order रे गोटे थिला तमर एटा cyanohydrin आ गोटे ascending order अछि. तो एटी aldehyde convert होइछ terminal position रे. So आ गोटे ascending order तुम कहि परिबो that is addition of cation, but cation add हुए only in haloalkane that to terminal position रे. ताले haloalkane केमति बनैबा? First same bromination करिबा. So from bromination we'll get 2-bromo propane. हमको terminal position पे we have to follow the method that is को मेथड हम फॉलो करिया पड़िबो. Yes, that is the elimination followed by addition of hydrogen bromide in peroxide. So alcoholic KOH, this will give propene, then addition of HBr in the presence of peroxide. Okay, then 1-bromo, then cation, cyanide, then hydrogenation, palladium, Rogerman reduction. So cyanide ru हम कोन बनै परिबो और तमे यूज कर परिबो डाइबल H भी यूज कर परिबो. So this is the reaction. Okay, this is the reaction. Quick. Make it fast. I hope all of you are writing. Next, last question. So last question is, you have to convert 2-methyl propan-2-ol to 3-methyl butanoic acid. Again, the increase in carbon number. Increase in carbon number. Then how to increase the carbon number? So this is the compound. First, you can make the dehydration. So this is the product after dehydration. Then we can use HBr in the presence of peroxide. Okay. So after this, what you can do? KCl, cyanide, then hydration. So write down the answer. Make it fast. तापर हमें जीवा. I hope all of you are writing. Okay. तापर जीवा किसी क्वेश्चन जोटा में आगुरी डिस्कस करिचे. So we'll discuss. First is the question related to that is cross kinase reaction. Crossed kinase reaction. So in cross kinase reaction, we have to take a cross kinase reaction of the last year 2025 JEE main question pachaythila. Okay, although it is not there in your board's syllabus, but some questions are being asked. Cross kinase reaction, even intramolecular kinase reaction upare भी question आसीथिला. तेलको जब हम cross kinase reaction देखिबा, we have to take a mixture of two carbonyl compounds. Both the compounds must not have any alpha hydrogen with them. And the medium must be concentrated alkali. Then what will happen? If two carbonyl compounds without alpha hydrogen are taken in the presence of concentrated alkali, then more reactive undergoes oxidation, whereas less reactive undergoes reduction. So the aldehyde oxidation hobo. So obviously that will be converted to salt of carboxylic acid. Why? Because the medium is alkali. Or the reduction hobo, then that will be converted to alcohol. Okay. Tell the one is formaldehyde, another is benzaldehyde in the medium of concentrated NaOH. The formaldehyde is that is formaldehyde is most reactive among all aldehyde and ketone. Tar reactivity reason kono? The first is it is sterically the least hindered, and second reason is there is no plus I group or electron releasing group to destabilize the carbocation center. So this undergoes oxidation to form sodium salt of formic acid, and benzaldehyde undergoes reduction to form alcohol. So write down this quickly. How's our mechanism? Try it once. Try the mechanism. जो mechanism में already kinetic reaction discuss करी थिले. So cross kinetic reaction same होगा. सेठी same कार्बन को अटैक करथिला. एठी two different कार्बन को अटैक करछि. Write down. So I hope all of you written this. ये concept लिख लो तापर mechanism. Just 2 minutes try करो. तापर हम discuss करियो. Only 2 minutes. Try. Only 1 minute, then we'll discuss. Okay. তাহলে আমি যদি দেখি এটি step 1. In step 1 কোন ছিল না attack of OH minus hydroxide as the nucleophile. কাହିଁକି ନା ଏଠି base କେତେବେଳେ act କରିବ ଯଦି କିଛି acidic hydrogen ଥିବ. So here in both the compounds alpha hydrogen is absent. তাহলে acidic hydrogen is not present here. So the OH minus cannot act as base, rather it will act as the nucleophile. This nucleophile of it will attack to the more reactive site. So the more reactive site is carbon. So this is the first step. Okay. So step 1, attack of the hydroxide as the nucleophile to the carbon center. Okay, or carbonyl carbon. So second step, hydride transfer. Just try to recall hydride transfer. And it is the slow step. And slow step means this is rate determining step. RDS rate determining step. जोटा भी slow step था तो already chemical kinetics रे that becomes the rate determining step. So it हम देखिए benzaldehyde. So hydride transfer. This will make double bond. So this PHCO minus H2. The reaction is not over 8 because between carboxylic acid and phenol, which is or any other alcohol, phenol or any other alcohol, या तो phenol other alcohol, which one is more reactive. or more acidic? Phenol or carboxylic acid or any other alcohol, which one is more acidic? Carboxylic acid is more acidic. If carboxylic acid more acidic hela, tale जो alcohol or phenol ro conjugate base रहिबो, that must be the strong conjugate base. The strong conjugate base होबो, then the shifting will be taking place. Okay. So एठी कोन होबो ना acid base reaction. So acid base reaction hele or our hydrogen will be transferred, and in the presence of Na plus, it will be salt of carboxylic acid plus this alcohol. Quickly note down. In cross kinetic reaction, the more reactive aldehyde undergoes oxidation, and the less reactive aldehyde undergoes reduction. Make it fast. Note कर दिया student. 'Okay'. So don't complete no करছো, keep on writing, and I write one more question. Write down. Write down this. Two minutes. Question complete करो. Doing, students. Okay, जमती टिके संपूर्ण हम कोई थिले केदन ट्राई कलो स्टूडेंट कैन यू रेज योर हैंड sorry can you raise your hand how many of you tried? So just before some time we have discussed which is more reactive among these two. Among these two or among all the aldehyde and ketone, formaldehyde is most reactive, right? Formaldehyde is most reactive. Since formaldehyde is most reactive, so that undergoes oxidation and the other one undergo reduction. But the question is here, in the previous case, previous example हम देखते ले, both formaldehyde and benzaldehyde were present in equal molar ratio, but here it is not so. এটি কোন আছে? One is 1 mole and another is 2 moles. So obviously we have to apply the concept of limiting reagent. The limiting reagent concept কোন ଥିଲା মনে পকাও না, the substance which is present in lesser quantity will be consumed first and that will decide the fate of the product formation. Okay, তাহলে এটি আগে কি কনজিউম হবে? This is which is the limiting reagent. So limiting reagent রে কি আছে না, limiting reagent আছে formaldehyde. So formaldehyde will be consumed first. তার মানে 1 mole of formaldehyde and 1 mole of trichloro 2 trichloroethanol. Okay, 2 trichloroethanol will undergo reduction. তাহলে 1 mole each use হইব, যদি 1 mole each use হব, then so oxidation যে বনিব that will give the salt of carboxylic acid. Here potassium salt of carboxylic acid 1 mole, and this will be converted to 1 mole. But the reaction cannot be stopped here. कहेंगे ना, जो 2,2,2 trichloroethanol is present, that is 1 mole. So 50% of that 1 mole, not 1 molecule, then 50% of that will undergo oxidation and remaining 50% will undergo reduction. যে oxidation হবো তাহলে আমি কোন লিখিবা না plus CCl3 then COK. This is the oxidation product, and the remaining reduction product OH. So it is 0.5 mole, and this is also 0.5 mole. So in total, I mean, so this one becomes 1.5 mole. So write on this, students. Quickly write on this. Okay, complete. Next, this is the concept of cross cannizzaro reaction. Then intramolecular cannizzaro reaction. What a question! A वर्ष JEE मैंने पचातिला 2025. Intramolecular cannizzaro reaction. Okay, so intramolecular cannizzaro reaction कौन लागुचे? Now within the molecule cannizzaro reaction will take place. How within the molecule cannizzaro reaction will take place? Now this, suppose we are taking a cannizzaro reaction concept in the absence of alpha hydrogen. So suppose we are taking this in the presence of concentrated KOH. In the presence of concentrated KOH. Then say how the reaction will proceed. Yes, alpha hydrogen nahi. KOH is present, so that can act as the nucleophile. So the nucleophile over, so it can attack to the carbonyl carbon, which is more reactive. So this one, this center. So then we can write pH okay. First step is clear. Then at the adjacent position, what is present? Another carbonyl carbon. So hydride transfer. ଯଦି इंटरमोलिकुलर हाइड्रेट ट्रांसफर होउथिला ताले इंट्रामोलिकुलर हवार किछि भी प्रॉब्लम नै इजियर इंटरमोलिकुलर रिएक्शंस आर faster than the intermolecular. So this step जोटा hydride transfer, this step is the slow step and hence a rate determining step. So in again it will make the equilibrium reaction. So the equilibrium reaction of then it will be OH, H, C double bond, O, O, Na in the presence of Na plus. Write down. This is the example of intramolecular canister reaction. Make it fast. नोट कर दिया फटाफट स्टूडेंट तापर हमें आ गोटे एग्जांपल देखियो I hope all of you are writing. Okay, write one more question. Same, the example of intramolecular. It just this is not Na plus that I'm starting with K ଦେଇଥିଲେ ସେଟା K plus ହେଇଯିବ. Okay, try this question. Quick. ये क्वेश्चन ट्राई करो. 2 minutes. Same pattern रे reaction हबो. Okay. See, first, both are same. Since both are same, তাহলে এটি আমার কিছু পাখে চয়েস নাই যে which one will undergo oxidation and which one will undergo reduction. So oxidation, anyone can undergo oxidation and the other one will undergo reduction. The oxidation however, that will make the anion. So since it is making the anion, so this anion can act as the nucleophile. So next step रे कौन होगा? Now the product will be write down ester बन जाओ, cyclic ester बन जाओ. The product is cyclic ester. Make it fast. The right one to question. Right. Take formaldehyde first. Complete these two reactions. Quick. 2 minute time now. Solve this question. Hope all of you are trying. Dadike complete kalo. Write in the chat box. If anyone has completed. Okay, okay. Continue. Last 1 minute. Quick student. Okay. So first, in first one, if you'll see, in first one, ethanol contains acidic hydrogen, whereas the formaldehyde doesn't have any acidic hydrogen. Okay. So ethanol contains acidic hydrogen, and in the presence of dilute NOH, what will happen? The acidic hydrogen will be released out to form acid hydrogen will be released to form the carbanion. This is the first step. This carbanion now can act as the nucleophile, and it will attack to other carbonyl carbon, that is none other than the formaldehyde. That is none other than the formaldehyde. Okay. So in the next, in the presence of water, this is the compound. So this can easily lose water molecule, easily lose water molecule to form the compound. Write down. Kahingi na this will be the conjugated. So this one is complete. Second one, first question try kariparnathilo. Try the second one. Okay. Take 1 minute. Eta note karo. Second one fatapat try karo. Similar way. It hamarachi acetone. Acetone contains alpha hydrogen. So that will be converted to carbanion. Then it will attack to benzaldehyde. फटाफट लगा. Make it fast. So second question. So second question, in the first step, acetone releases alpha hydrogen to become the carbanion. Okay. So the carbanion formed acts like the nucleophile for the second reaction. So it will become then by taking H plus from hydrogen, sorry, from water, it is converted to, okay. Next, the release of water, as it is the extended conjugation. So final product will be this is the product. Note down. Okay, student, note करो. So after this, we'll discuss oxidation and reduction. So I hope all of you are writing. Quickly note कर दियो. Just 1 minute. And then ब्रेक हम ब्रेक पर आम डिस्कस करा खाली मु ब्रीफ कर दउची ऑक्सीडेशन रिएक्शन सो ऑक्सीडेशन रिएक्शन अंडर देखिबा बाय strong oxidizing agent like alkaline KMnO4 acidified K2Cl2O7 or chromic acid. Then second by mild oxidizing agent. What are those? Tolerance reagent, then Fehling solution, then Benedict solution, then Skipp's reagent. Okay, so these are the cases of oxidation reaction. तापर हम देखिबा reduction reaction. The reduction reaction. Under the reduction reaction, first by strong reducing agent like Clemenson reduction, then a strong reducing agent or complete reduction. Clemenson reduction, whole prisoner reduction, then HI in red phosphorus. Then by or partial reduction. Complete न लिखि ताको हमें partial reduction लिखिबा. So partial reduction. First is complete reduction, second is partial reduction. So these are the topics we'll discuss after the break. Okay. So now the break is started for 10 minutes. Then after the break, we'll continue the class. We'll discuss first oxidation, then the reduction of aldehyde and ketone. Welcome back, students. Now we are going to discuss the oxidation and reduction of aldehyde and ketone. First, oxidation of carbonyl compound, that is aldehyde and ketone. So under that, oxidation of aldehyde. If you are writing the structure of aldehyde, then in the presence of strong oxidizing agent, let's say alkaline KMNO4, this bond HO bond can easily be oxidized. If oxidation hobo, then what will be the product? Just think, what will be the product? Yes. Quick. Kotha bhabo. Can it be easily oxidized, or it will be difficult to oxidize? It will be easily oxidized. Why it will be easily oxidized? Because the CH bond present here, the CH bond present here can be easily oxidized to give the OH. Okay, to give OH. So this is easily oxidized, or you can say aldehydes are easily oxidized to give carboxylic acid. Write down. Aldehydes are easily oxidized to give carboxylic acid. And what about ketone? Can it be easily oxidized? No. In case of ketone, there is, there is no hydrogen attached to, the C2H5 nahi pariba. Hydrogen attached to the carbon, directly attached to the carbonyl group to get oxidized. So here it will be no reaction. Okay, in general, there will be no oxidation when ketones are exposed with the strong oxidizing agent. But it may undergo oxidative cleavage. It may undergo oxidative cleavage. The question is oxidative cleavage kemti hobo? On both sides of the carbonyl carbon under rigorous oxidation. So rigorous oxidation hele kon hobo na it will undergo oxidative cleavage to give a mixture of carboxylic acids on both the sides. Ta mane jodi ame ethi rigorous oxidation hobo on one side 2 carbon achi, 2 carbon means this will be ethanoic acid, and the other side this will be pentanoic acid. And if it undergoes oxidation on other side, then the product will be first C4H9. C4H9 means C3H7 COOH plus other side kon hobo na C2H5 COOH. So these are the products. Note down. तामने में कौन कहबा ना aldehydes can easily undergo oxidation to form carboxylic acid, whereas ketones do not undergo oxidation under normal condition, but under vigorous condition the oxidative cleavage takes place to form a mixture of carboxylic acids. To form a mixture of carboxylic acids. Okay. So this is the oxidation by strong oxidizing agent. Next is by mild oxidizing agent. So mild oxidizing agent, first we'll discuss tolerance reagent. Up to this, any difficulty, students? Any difficulty up to this? If yes, then you can raise your hand. Okay. Next, tolerance reagent. What is tolerance reagent? It is ammonical silver. Mute yourself. Okay. So, student, all of you are requested to mute yourself. Then, ammonical silver nitrate solution. So, what is the role of this tolerance reagent? Write down. Tolerance reagent oxidizes both aliphatic as well as aromatic aldehyde. Oxidizes both aliphatic as well as aromatic aldehyde to give salt of carboxylic acid whereas itself get reduced to form silver metal which is commonly known as silver mirror. Silver metal which is commonly known as silver mirror and is deposited on the walls of the test tube. Deposited on the walls of the test tube. ताकि हम सिल्वर मिरर बोली कहूचे. ओके ताले हम कोन के देखियो इट इज अ टॉलरेंस रिएजेंट अछि दैट इज रिड्यूस्ड आ सीधे रिड्यूस हबो से काहा को ना काहा को ऑक्सीडाइज करिवो सो काहा को ऑक्सीडाइज करिवो ना aldehyde को ऑक्सीडाइज करिवो. So we can write the reaction aldehyde RCHO and tolerance reagent ammonical silver nitrate. Okay. And basic medium OH minus, it gives the product. ताले यदि CHO oxidize हबो basic OH minus अछि, so that will be RCO minus plus Hg plus ammonia तो release हबो ही हबो plus water. ताले तो आपको हम balance करी परिबो. फ्रेंड फटाफट balance करो. Make it balance. You can put 2 here. 2 means ammonia will be 4, Hg will be 2, and water will be also 2. This is the balanced form. And as I told you, it oxidizes both aliphatic as well as aromatic aldehyde. It oxidizes both aliphatic as well as aromatic aldehyde to form the salt of carboxylic acid. Okay, so note down. और से हम जे देखिबा फेलिंग सॉल्यूशन ओनली aliphatic aldehyde को ही कौन करे ऑक्सीडाइज करिवो नॉट aromatic aldehyde. Okay, so next is other reactions shown by the tolerance reagent. Now it oxidizes like करिवो oxidizes formic acid to give CO2. So what is the structure of formic acid? This is structure of formic acid. हम जे देखिबा this one it is similar to aldehyde. So carbonyl carbon अच्छे similar to aldehyde. ताले ये दे oxidize होबो tolerance reagent लिखिबा. So that will be converted to CO2 and the tolerance reagent will be reduced to silver. Okay, silver metal. So in the solid form. And what are the other reactions? Now it doesn't affect olefin bond. It doesn't affect olefin bond. So olefin bond means carbon-carbon double bond को. So the हम गोटे compound लिखिबा. If it is asked this compound to be converted to this. Okay, तो then me conversion करिबा. So which reagent is to be used successfully? Yes, which reagent is to be used successfully for conversion of this? हमें जब देखिए alkaline KMnO4 नवा or acidified K2Cr2O7 नवा, then the problem will be the carbon-carbon double bond or olefin bond that will be also oxidized to give से oxidase कौन बनेबो से भी carboxylic acid बनेदेबो. तामाने that can react with the olefin bond. So एमिते में reagent नवा जोटा कि olefin bond से react कर नथिबो. So the best reagent will be here the tolerance reagent. Okay, we can use the tolerance reagent here. Then another, it oxidizes alpha or beta alpha hydroxy ketone. It oxidizes alpha hydroxy ketone. Last year means 2025 JEE main re pachariଥିଲା. So if you are going to take so tolerance reagent, this is the reaction. So quickly note down this. तापर हमें next ଯିବା. Quick student. नोट कर तो क्विक ओके ताले हम जदि देखियो ओवरऑल को एनालाइज करिबा सो इट ऑक्सीडाइजेस the aliphatic as well as aromatic aldehyde. It oxidizes formic acid to give carbon dioxide. It doesn't oxidize or doesn't affect the olefinic bond or carbon-carbon double bond. Then it oxidizes alpha hydroxy ketone. Okay. So, ये ला तुम्हारा tolerance reagent. Then next is Fehling solution. So how the tolerance reagent doesn't react with ketone. It may be aliphatic ketone or aromatic ketone. It doesn't react. Okay. So next is Fehling solution. So Fehling solution kona? Now Fehling solution is equimolar mixture of Fehling A and Fehling B. What is Fehling A? Fehling A is aqueous copper sulfate. Okay, aqueous copper sulfate. So aqueous copper sulfate मैंने जनरल हम जानते हैं जो ब्लू कलर था CuSO4.5H2O aqueous copper sulfate. Then Fehling B. So Fehling B is what is Fehling B? What is Fehling B? Student, please mute yourself, all of you. So Fehling B is that is a colorless solution जोटा कि potassium sodium tartrate. That is potassium sodium tartrate जोटा कि alkaline solution था. First थिला कौन aqueous solution of copper sulfate. This is alkaline solution of potassium sodium tartrate that is commonly known as Russell's salt. Okay, Russell salt. So while preparing Fehling solution, we have to take equimolar of Fehling A and Fehling B. Equimolar of Fehling A and Fehling B. Okay, so then only we can make that is Fehling solution. So when Fehling solution is treated with aldehyde and ketone, then for aldehydes are of two types. As you know, one is aliphatic, another is aromatic. So aliphatic aldehyde, yes, it will give positive test. Aromatic aldehyde, it will give negative test. तामने question, जदि हम पाखरे अच्छी, the two solutions are there. One is aliphatic aldehyde, another is aromatic aldehyde. We do not know which one is aliphatic, which one is aromatic. If we tolerance reagent, the tolerance reagent will give the positive test to both aliphatic as well as aromatic. But Fehling solution, the Fehling solution will give positive test to the aliphatic only and negative test to the aromatic aldehyde. I think it is clear. Tale, Fehling solution will act upon only the aliphatic aldehyde. So now we are going to discuss the reaction of failing solution with aliphatic aldehyde. So aliphatic aldehyde or CHO and failing solution this will be CO2 plus cupric, and in basic medium that will give basic medium our salt that will be in the form of anion. Then CO2 plus will be the aldehyde oxidize hochi tale cupric kon hejibo reduce hobo. So reduce hele CO2 plus ru kothre convert hejibo Cu plus. So that will be converted into cuprous oxide along with water hele 3 water hejibo. Tale एठी हम देखिबा दि CO2 plus tale this is 2 and 2 okay it is 5. The cuprous oxide banuchi, so it will be in the form of red brown precipitate. So it is cuprous oxide is red brown precipitate. Ta mane hame tolerance reagent au failing solution both को use करी परिवा, both को use करी परिवा, कौन पे use करीबा ना for detection of aldehyde. Okay, so both will oxidize aldehyde, and again failing solution will oxidize only aliphatic aldehyde. So note karo. Upon the clear, student. Now, what are the other reactions shown by the failing solution? Now, other reactions are it can oxidize same. जदि हमें देखिबा तो same reaction लिख परिबो. It can oxidize formic acid to give carbon dioxide. It doesn't affect olefinic bond. It oxidizes alpha hydroxy ketone. आपको टिके माने शॉर्ट रे नोट करि परिबो. Quick. What about a note कर दे student? तापर देखिबा Benedict solution. Then we'll go to the reduction of aldehyde and ketone. Benedict solution. What is the role of Benedict solution? Now it oxidizes only aliphatic aldehyde like the failing solution. Okay, like the failing solution. So एठी reaction almost similar होबो like the failing solution. कहेंगे ना एठी जो Benedict solution होची that is cupric sulfate. Okay, sorry, cupric citrate, sulfate में cupric citrate. एठी cupric ion है. Cupric citrate will be reduced to CO. Okay, to CO, and the aldehyde that will be converted to the salt of carboxylic acid. So, this reaction like for you same way. CO2 plus OH minus, that gives CO minus cuprous oxide and water. So the balance karibo, this is 2 and this is 3 and 5. Write down. I hope all of you are writing. Then we'll go to the reduction of aldehyde and ketone. Reduction of aldehyde and ketone. So under the reduction of aldehyde and ketone, first point we'll discuss partial reduction. First point we'll discuss partial reduction. How the aldehydes and ketones undergo partial reduction. Okay. So partial reduction under kon dekhiba. The reagents are catalytic hydrogenation or using lithium aluminum hydride. So if you'll take aldehyde catalytic hydrogenation, so it will be reduced to give primary alcohol, and the ketones are reduced to give secondary alcohol. हम जन देखथिले कोन ना aldehyde ketone undergo partial oxidation, sorry, alcohols. Primary alcohol undergoes partial oxidation by PCC or CrO3 pyridine to give aldehyde, and secondary alcohol to give ketone. जदि partial oxidation रे कोन होथिला ना aldehyde की ketone बनथिला, सेंति partial reduction रे कोन बनिबो ना aldehyde रो primary alcohol and ketone रो secondary alcohol. Note down, student. Quick. Can we use NaBH4? Yes, we can use also NaBH4. I'm going to say sodium borohydride is comparatively less stronger than the lithium aluminum hydride. Okay, note down. तापर हम देखिबा complete reduction. Complete reduction. So under complete reduction, so we'll discuss first is Clemmenson reduction. So what are the reagents taken in Clemmenson reduction? The zinc amalgam with concentrated HCl. Zinc amalgam with concentrated HCl. Okay. So what will be the product? Now it may be aldehyde or it may be ketone. It may be aldehyde or ketone. When those are treated with this Z energy HCl, those are completely reduced to give alkane. Those are completely reduced to give alkane. Write down. Then ketone nava same. This is Clemmenson reduction. Complete. Next is Wolff-Kishner reduction. So which are the reagents taken for Wolff-Kishner reduction? The reagent is hydrogen. Reagent is hydrogen in the presence of the base alkali, that is KOH or NOH you can take. Okay. So KOH or NOH. And we know KOH is strong as compared to NOH. তাহলে আমি এটি কোন নেব একটা strong base নেব along with hydrogen. তাহলে এটি কোন নেব same like the Clemmenson reduction. Aldehydes are treated with hydrogen in the presence of strong base to be reduced to give alkane. To be reduced to give alkane. Similarly, ketones as well.
বউ ব্রশ করতে হ্যাঁ ব্রশ করলু ମୁଁ ଧନୁ ମୋର ଲାଗିଛୁ
Complete Wolff-Kishner reduction. Next. Next is reduction by HI in red phosphorus. So same. Write down. Complete. Okay, children. Now write some conversions. Write some questions. These are the conversion reactions. Okay. A 5 question conversion करो. फटाफट try करो, then we'll discuss. Student, all of you are trying. Make it fast. So तुमने try करो, then we'll discuss. Quick. So, कितना student complete color? Raise your hand. How many of you completed? Okay, keep on trying. Make it fast. I hope all of you tried. Okay. Now we are going to discuss. First, it is alcohol to alkane without changing the number of carbon atom. तर अल्कोहल को हमें अल्केन रे डायरेक्टली कन्वर्ट कर परिबानी दीटा वे कर परिबा फर्स्ट जो देखिबा in the presence of concentrated acid it will be undergoing dehydration to form alkene. So alkene को hydrogenation करो, it will be alkene. This is one way. Okay, this is one way. Then other way कौन कर परिबा? Use PCC. Then Clemenson reduction or Wolff-Kishner reduction. This is first question. Second is aldehyde. Aldehydes are just doubled. Okay, number of carbon atoms present in the aldehyde gets doubled. So that is the easiest way we can take, that is none other than the aldol condensation. So first it is ethanol. Okay, so जदि हमें ताको नबा dilute alkali. So dilute alkali will be converted to so after heating this is the second question. Note down. Then third, there is increase in one carbon number. There is increase in one, increase by one carbon. तो केमते हम करिबा one carbon पे मन पकाओ सबुठो easiest way थला केशियन, बट केशियन हमें कहाँ से तो नबा केशियन को हमें रिएक्ट करिबा विथ हालो अल्केन. सो हियर इट इज इथेन. सो इथेन को हमें इधर क्लोरिनेशन करि परिबा और ब्रोमिनेशन करि परिबा. So it will be converted to chloroethane. So chloroethane is treated with Caesium, to give this. Then को cyanide में aldehyde केमती बनेगा Rosenman reduction और diol H नहीं परिबा. So you can use diol H. You can use diol H. This is the third question. Note कर दिया student. Over. Next diba. Next is benzene to metanitrobenzaldehyde. So हम देखिए benzene is converted to metanitrobenzaldehyde. तो माने हमें दे आगो बेंजाल्डिहाइड बनेबा, बेंजाल्डिहाइड को नाइट्रेशन करिबा, then that will be converted to metanitrobenzaldehyde. So how to get benzaldehyde directly from benzene? मन बताओ. That is Gattermann-Koch reaction. So in Gattermann-Koch reaction, reagents are CO, then HCl along with anhydrous LCl3. It is converted to benzaldehyde. Then with benzaldehyde, nitration, concentrated HNO3 in the presence of H2SO4. Concentrated HNO3 in the presence of H2SO4, that will be converted to meta-nitrobenzaldehyde. And the last one is benzene to para-nitrobenzaldehyde. तो नोट न कर स्टूडेंट नोट कर दियो. Benzene is converted to para-nitrobenzaldehyde. How? ना मेदी आगो benzene रो benzaldehyde बनेगा. We cannot get para product. We will get the meta product like the previous case. तो माने एठी हम कोन करिया पड़िबो alkylation करो. So after making alkylation, it will give toluene. So toluene undergoes nitration HNO3 in the presence of concentrated H2SO4. Okay. तापरे bromyl chloride इटा reaction कई परिबा. So that will be converted to para-nitrobenzaldehyde. Note कर दियो स्टूडेंट. Quick. I hope all of you are writing. Complete. Okay. तापर हम देखिबा किछि sequence of reactions. Then write down the questions. Three questions only. This is tolerance reagent. Write on the product. Make it fast. Who is students? Then we'll discuss. I hope all of you tried. Okay. Now I'm going to discuss, and after discussion, we'll wind up the class. First is it is CH3CH2OH. So PCC, primary alcohol will be converted to aldehyde, and HCN, addition of HCN, okay, then ताको तमे hydrolysis करिबा, CN will be converted to carboxylic acid. CN will be converted to carboxylic acid. Note करो. Next is next देखो. First it is given acetone acetone in the presence of dilute KOH or dilute alkali. Kon habo? That undergoes aldol condensation. The aldol condensation habo, then the product will be S this, and when this aldol is heated, the double bond will be formed on the side of the carbonyl compound. Next, third and last question for today. Okay, so it is the compound and tolerance reagent. Tolerance reagent, as you know, doesn't affect the H plus VH, so doesn't affect the olefinic bond. So then hydrogen bromide add kariba. So that gives okay. So this is the product, not all. So if you have noted, then you can leave the class. If you have completed writing, then you can leave the class. Okay, students, thank you for being in my class. We'll meet in the next class.